Hey guys, we are on day 6 notes, and again, we see this diagram for the third time, trying to get you guys more familiar with it. And so we'll go ahead and quickly fill it in. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, we'll do it a little bit differently. We know that all students take calculus, okay, that all of our trig functions are positive in quadrant 1, that sine theta is the only function positive in quadrant 2, the rest would be negative, that tangent theta is the only positive trig function, the rest are negative, and in quadrant 4, cosine theta is the only trig function positive, the rest are negative. Okay. We'll go around our circle. This is 0 degrees, 90, 180, 270, 360. If we go backwards around it, we have negative 90 down here, negative 180, negative 270, and negative 360. Okay. We'll go around with radians as well. So remember that this would be 0 radians. Okay. That 180 degrees is pi radians. That 90 degrees up here is pi over 2 radians, and that 270 is 3 pi over 2 radians. Okay. Filling in the negatives, oops, I forgot 360 is 2 pi radians. Okay. Let's see, negative 180 degrees would be negative pi radians. Down here, we'll go negative pi over 2 radians for negative 90. And up here, negative 3 pi over 2 radians for negative 270. And negative 2 pi radians for negative 360. Okay. Onto the unit circle. If we graph this point on the unit circle, we are at 1, 0. If we go the opposite direction and graph this point, that would be at negative 1, 0. If we graph this point up here, that's at 0, positive 1. And down here is 0, negative 1. Okay. Inside of our triangle here, we know that this is theta, that the length of the hypotenuse of our triangle is 1, because that's the radius of the unit circle. Okay. This is our x distance. This is our y distance. However, x is also known as cosine theta, and y is known as sine theta. So this point up here would have coordinates of cosine theta, comma sine theta. Okay. We can also call this our opposite side, and this is our adjacent side, and this is our hypotenuse side. All right. So we're going to use more of this triangle here in today's notes, and we're going to move it around into the different quadrants to find the exact values. All right. So coming down, it says finding exact values of trig functions. Okay. We're going to go ahead and draw a right triangle in the correct quadrant. Be sure to draw it to resemble one part of our bow tie here. So depending on what quadrant you are in will depend on what your triangle looks like. Okay. We are going to label 2 sides of the triangle based on which trig function we were given, and we're going to ignore all negative signs. Okay. We'll take care of our negative signs with all students take calculus. Okay. Using our Pythagorean theorem, a squared plus b squared equals c squared, we'll be able to solve for the third side since it's a right triangle, and we'll set up the fraction that represents the trig function asked for. Okay. We'll use all students take calculus to determine if our answer should be positive or negative. So here we go. In number 1, it says if tangent theta equals negative square root of 7 over 3, and theta is a 4th quadrant angle, find the exact value of cosine theta. All right. So because they said it's a 4th quadrant angle, we'll go ahead and draw our right triangle. So we always start at our origin, and we go over x amount and down y amount, okay? And then we connect it. And that's our right angle. And theta will always be the angle closest to the origin, all right? And so you guys can see in our picture here, we're drawing that part of our bow tie because we are in the 4th quadrant, okay? So because they gave us the tangent theta, we know that according to SOHCAHTOA, some old horse caught another horse, taking oats away. That tangent is opposite on top, adjacent on the bottom. So this is our opposite and this is our adjacent. And remember they said to ignore all negative signs, okay? So in our right triangle down here, this would be my opposite side and this would be my adjacent side. And we know that the opposite side is the square root of 7 and that our adjacent side is 3. Okay? We're going to go ahead and take a squared plus b squared equals c squared. And we're going to solve for our hypotenuse side. All right. So therefore, we don't know the hypotenuse, we don't know c, and therefore the two sides we have can go in for a and b, and these could be switched. Okay. So square root of 7 could have gone in for a, 3 could have gone in for b. All right. 3 squared is 9. Square root of 7 squared is 7. And 9 plus 7 is 16. And we'll take the square root, and c is going to come out to equal 4. Okay. Now when they ask us for the exact value of cosine theta is equal to adjacent over hypotenuse, and my adjacent side is 3, and my hypotenuse is now 4. And down here in quadrant 4, all students take calculus. Cosine is positive, and so we can leave our answer as positive 3/4. We do not need the negative on it, since in the fourth quadrant, cosine theta is positive. And we figured it out, all right? We could also be able to solve for theta if we wanted to, or if they asked, all right? All right, I will see you guys on the next page of notes for some more practice.